So now to illustrate one of the common problems with PBR rendering, which is to do with reflections and highlights. I've got a scene set up here, the standard sphere on a grid, and I'm going to attach some materials to the sphere. Let's put clay material onto the floor. And then I'm going to put a reflective material onto the sphere. And we've got an area light illuminating the scene. Let's just see what this looks like when we render. And we can see if we zoom in here, we're getting slightly strange double highlight here. We've got a very sharp highlight in the middle and then a blurry highlight around the outside. And the reason for that is because we have both reflections enabled and specular enabled. And with reflections enabled, we're getting a direct reflection of the area light source itself. But we're also getting a specular reflection of the area light source. And in fact, all specular reflections are an approximation to the real reflection. So essentially we're getting two reflections of the light source. We're getting one which is blurred using the glossy specular function, and we're getting one pin sharp reflection which is produced by the reflection element of our shader. And this is fine if we want to imitate a material which has two layers, a very sharply reflective layer on the outside and then a more blurry layer on the inside. So for example, an object that's coated with lacquer or has a very highly polished surface might exhibit something like this. But in general you'll want to turn the specular element right down if you're using reflections. And as you can see, we still get our reflected light source, but the blurry reflection has disappeared. Now by default the reflections are perfectly sharp. They are controlled here in the Ray Trace tab of the Reflections tab, and as you can see we have something called cone angle here. That determines how varied the rays are that get sent out to calculate reflections, and in this case they're all going to head in exactly the same direction, so we'll get a very sharp reflection. What happens if we want to blur our reflections and not get quite such a sharp reflection of the light source? Well, we can change this value, and in general you don't need to change it to a very high figure to get some blurry reflections. This is measured in degrees, so even a 5-degree variation in the rays is going to produce quite a blurry effect, as we will see. And we can see already that we're getting a blurred effect here in terms of the reflection of the floor. We don't seem to be getting such a blurred effect with regard to the light. Let me pause this and let it render through. Well, here we are. We can see that we have quite a blurry reflection of the floor, but this seems to be quite sharp. Well, what's the reason for that? The answer is that what we've got here is an area which is so highly bright that it's not reflecting the fact that in fact this is a slightly blurred highlight. And I can demonstrate that in two ways. One, if I hit the I key, brings up an inspector, And as we can see that on the outside of this highlight we've got values of 21, and towards the middle we've got values of 111 or 130 even. So it is in fact tailing off, but because all of this is outside the 0 to 1 range, we're getting this jaggedy effect. Another way to look at this is to bring up the display options, rather the color correction options, and then I can hit this button here which equalizes the image. Now we can see that we've got a blurred highlight, but the problem is that the rest of the picture has disappeared because it's so much darker than our highlight. What can we do to correct this? Well, in some circumstances this is actually what you want, because if you're going to output your image to a compositing program which can do tone mapping, then you may want to preserve this highlight and save your image in a 32-bit float format or a 16-bit float format, and then the compositor can adjust this so that it looks proper. Unfortunately, the Houdini compositor doesn't come with any tone mapping functions by default, so it's quite tricky to achieve that result in the Houdini compositor. Alternatively, there is a render option which you can use to tone down highlights like this. Unfortunately, the option is not by default part of the mantra node, although it is recognized by the renderer. So we'll need to edit the parameters on our mantra node, edit rendering parameters, and the parameter we're looking for is called color limit. And if we look under the mantra 10 options, we have color limit here, and we can just drag and drop this across into our window here, and let's put it under the main options perhaps. Okay, and then we accept that, and then if we have a look at our main options we should find that now we have a color limit, and that's quite high by default, 1024. If we turn it down to something like 1.5 and then re-render, we lose the high dynamic range nature of the highlight, which is a good thing if we're just going to output this image directly into a movie, but is a bad thing if you're going to want it for compositing later on. Let me just demonstrate that by bringing up the pixel inspector using the I key, and we can see that now the brightest pixels there are only 1, and that it has a nice blurred edge, as we would expect. So that's a very brief introduction to some of the features of physically based rendering in Houdini. I hope it's been useful.